I'd like to introduce Dr. Krystyn Van Vliet. She is the committee co-chair of the Decadal Survey on Biological and Physical Sciences Research in Space for 2023-2032. And she is also the Michael and Sonia Kerner Professor of Material Science and Engineering at MIT. And she'll be giving us a talk today on the Biological and Physical Sciences Decadal Survey. So welcome, Krystyn.
Thank you so much, Kevin, and thank you to you and Lisa for all the behind-the-scenes work to get ready for today, as well as to Craig and Fran and Brad for those introductory remarks. Really happy to be with you here today. And as was mentioned, part of my role here today is to update you on where we are on the Decadal Survey, a process in which the white papers are such an important component, and give you a sense of where this is going, but also to listen and to learn. So I'll be participating in the workshop today to really hear and listen to this part of the space science community. So we appreciate all your engagement today and throughout the process. As was mentioned, I am the Decadal co-chair. The other co-chair is Rob Furl of the University of Florida. And I have an engineering background, both in materials engineering and biological engineering. I also have administrative roles at MIT that give me a perspective on this problem that I'll share with you on the next chart. So next, please. So this is obviously a picture of the lunar surface, the focus of today, with a view to Earth. It's one of the things that I want to make sure we get across, and one of the things that I've learned in my other roles at MIT, is that we have these opportunities in front of us. And part of what the Decadal Survey helps us to recognize is all the opportunities, all the ideas that we could do in the space environment to enable space exploration, to do transformative science, to gain new knowledge for the Earth, as well as about the lunar surface. When we think about that in terms of physical space on a university campus or any research environment, part of my job is to be in charge of how we operate our campus space at MIT. And I say, you know, campus space is not the final frontier. It's really a constraint optimization opportunity. And that's really how the Decadal helps us think about the opportunities we have in front of us when it comes to the lunar surface and the science at and about the lunar surface. There's so much we can do. There's so much that's important to do. How do we actually think about the constraints and how to get the best out of each other, the systems, and the platforms that we have available? So we'll go to the next chart, please. So just to give you briefly some background, if the Decadal surveys are new to you, and I know we've got some people who want to go on mute, the Decadal surveys feel new to you.
There's a hot mute, sorry, a hot mic. Can you please mute your mic? 25 megabits per second. Or Ricky, can you please mute their mic? Thank you.
So wherever you live, now you can do more of everything you want.
I'll keep going here. So thanks. So if the Decadal surveys are new to you, we'll give you just a little bit of background on their general purpose, because in any given community, by nature of the fact that they're called Decadal, they only come up every decade. And so some of us have seen this process before for the research areas of interest to us, and others have not. So they are a mechanism or an effort by the national academies, the National Academies of Science and Engineering and Medicine. And those academies were chartered originally as the National Academies of Science by President Lincoln in the 1860s. And today, there's hundreds of expert committees that are active at any given time to make advances and gain information and provide insight to the US government from the science community. And it's financed by what's called soft money, so study contracts and grants. The Decadal Survey is among those efforts. Next chart. So historically, and I think it's important to put this into context, when President Lincoln asked for the National Academies to be chartered, there was need for the scientific community to provide information. Here's an example from that first first request for a study for understanding the uniformity of weights, measures, and coin, right? The Secretary of Treasury needed some information, and you can recognize this as how the country marched towards issues of standardization, informed by the science community and to the benefit of the science community and the larger community. And that same approach, that same cadence exists today, in part aided by mechanisms like the decadal surveys. Next chart. So in terms of the decadal surveys that are specific to space science, there have been many over the years. As you think about your white papers and the framing of them, I might direct you to look at some of the ones in the past for understanding of how the white papers inform that process and what the final outcomes and products of the decadal surveys are. So this shows you some covers from several over the years. Biological and physical research in space had its last decadal in 2011. The current decadal is going on now, and I'll show you the calendar of how we're marching through this together in our very early stages. But you're welcome to read the prior decadal. That can be informative. It's not that the decadal that will come out now will be duplicative in format or intent, because so much has changed in the space science world, including the mission and including the knowledge base. Another of these reports that I could direct your attention to is, you see that cover sort of in the middle with a brown view to it that says a midterm assessment of implementation of the decadal survey. That's an important one to think about. How does the community use the decadal? How does your input and your interaction guide the development of a decadal? And how can we do better in using this as part of an instrument, as a signal to the government and to the community, the citizens of our country and the world, about what we're doing and how we stay accountable to that? So next chart. So in general, here's what any decadal survey, including the BPS decadal survey, aspires to do. First, to assess an entire scientific space, in this case, biological and physical science research in space environments. Second, to prioritize the key scientific questions. And here's where the white papers are particularly important in terms of taking the temperature and informing what is the scientific community's opinion. Those who are working in NASA, those who are working in universities, those who are working even in industry, where are the key scientific questions to be had? And then thirdly, to prioritize the associated work that would advance the research against those scientific questions, the engineering capabilities, the facilities, the practices for collaboration and data dissemination. And then finally, just to note that this effort, the decadal surveys, is performed independently of the sponsoring organization. So NASA has actually provided input on the statement of task. They are the sponsoring organization of this study. And yet the information that guides the process comes from the entire community. And the steering committee is independent of NASA in this regard, so that the approach can have the maximum benefit. And you can read more about the process or ask questions during the session today. Next chart. So the folks who charter a decadal survey are government agencies, and NASA in this case funded this and negotiates a statement of task with the national academies. So there was a back and forth over that statement of task over the many prior months so that we could get to the point, as Fran mentioned today, where we've now had the national academies appoint a steering committee. Rob Furl and I co-chair that steering committee, and that starts work against that statement of task. Now, who uses that decadal survey? The Congress, the larger scientific community in the US and also internationally, right? These are publicly available documents when they're released, and the federal agencies to have guidance on prioritization. Sponsoring agencies in the Congress also consider the decadal surveys as a very helpful prioritization document, and helps to set missions and objectives and give a mechanism of feedback and accountability in terms of what did we think the coming decade should prioritize. Understanding there's lots of uncertainty in any decade of science, especially in this particular area. Next chart. So the goals of the Decadal are to really provide the input, the documentation on a compelling program for the next decade in our space science community. What I wanted to emphasize here is this is not only about lunar surface science. This is not only about the moon. This will take us also on the way to Mars over the coming decade. It will also include suborbital and LEO. But your workshop here today is extremely important in articulating what is important about the lunar context, a very important part of the space environment, whether it's for space exploration or advancing knowledge. So importantly, the survey uses the white papers that you'll be discussing here today and community participation throughout the process so that these meetings are intentionally open to the public. Next. I'll just give you a sense of who receives these white papers and how does that process work in the next few charts before we open it up for more discussion. So the Decadal Steering Committee is a relatively large group of people, about 24 people, and the expertise is intended to span the biological and physical sciences broadly. So the folks on the steering committee who started meeting in earnest this week have expertise in biological sciences, physical sciences. Some of us work in both fields quite deeply, and I'm an example of that sort of crosstalk between the biological science and physical science communities. Engineering, technology, expertise in using shared facilities, including those available to us through the existing assets operated by NASA and others. The practices that enable good collaborative, transformative, and iterative science, and using different platforms, Earth-based and otherwise. So the steering committee has an important role in this process to integrate and prioritize the community input. We also have a responsibility to make sure there's broad and diverse participation from the community. The community here today at this workshop and the community more broadly in all kinds of environments of space and all kinds of perspectives and backgrounds to really bring the nation's best to this problem. The steering committee is also ultimately responsible to develop and then share the full report with the broader community. So we take responsibility for the full content. And we're informed by panels, and I'll share with you on the next slide our current thinking on the panels. Next chart, please. So the supporting panels are an additional group of experts. So we have the steering committee who has broad expertise, but certainly not deeply expert in everything that might be relevant. And so the supporting panels are an additional group of individuals also appointed by the National Academy, so not selected by the steering committee, but certainly all of us can contribute nominations. And then those folks bring an additional set of responsibilities. They help gather data and information, perform analyses, help develop the written material as directed by the steering committee. And so those supporting panels are in the process now of being nominated, appointed by the national academies, and those supporting panels, as well as the steering committee, will have direct access to the white papers that are submitted. Next chart. So the panels will comprise 3 different panels that will be integrated and working together on various tasks of the Decadal in the coming year. One panel with deep expertise and also broad across the biological sciences, from plants to omics and everything in between. Another panel with deep and broad expertise in the relevant physical sciences, so particularly relevant to today's discussion, materials, fluids, complex and otherwise, fundamental physics, including but not limited to quantum, combustion and fire safety. And so the workshop that you're running today and the concurrent sessions that you're running today, we want to make sure we have the kind of expertise on the panels to be good recipients of the information that comes forth in the white papers. And then on the far right, you see technical panel C. And those are a group of individuals that will have expertise related to the science and engineering interface of how do we actually do some of the research campaigns as well as the topical studies given the constraints as well as the opportunities in the coming decade of the laboratories that have been mentioned of various types, different platforms. Next slide. So this is almost second to the last chart, just to give you a sense of the timeline. So we're here in the far left of August 2021. There's been months of prior work going on, first to develop that statement of task, which is publicly available, and second to have the steering committee appointed. We're now in the process of populating the panels and then receiving the white papers. Now, in calendar year 2022, we'll have all the white papers received. And so that year will be focused on analysis, synthesis, meetings of the panels with the steering committee, meeting of the steering committee. And then what you also see in this green triangle here, this wedge, is trace, so technical risk and cost evaluation, particularly of these research campaigns. And as is clarified in the statement of task, the research campaigns are unique to this decadal, and so is this effort of trace, which is to think about if we had something like a 10-year effort for something like $100 million, what is the technical risk and cost evaluation of a particular research campaign idea? While it won't be exact, while there's lots of uncertainty, how can we have better thinking about that to guide the prioritization and guide the thinking about what we should do in the coming decade and what we should enable to maximize the chances of research success, and more importantly, the impact of that research success on the goals. So that will take us through to 2023, where in early 2023, the steering committee will finalize its report, submit it to the national academies for peer review, and then be able to respond to that review and then share out the report publicly in the summer of 2023. So while this is a long and intense journey, it very much relies on this component of the white papers for a signal of input from the science community, including all of you. So next chart, which is the last one. So these white papers are really an important outcome. While there's a brief and intense period over which they're solicited and due, this is one way to stimulate the ideas, the discussions you'll have today and during further white paper development on really two things. What are the compelling science challenges and frontiers that we should address in the coming decade? And then secondly, the so what. So it's important to be able to articulate what we should do. We all have research questions that are of interest to us, either because they advance new knowledge or we think that they can enable space exploration or improve life on Earth. But can we articulate that impact? So if the research is successful, if we're able to answer that scientific question that's put forth in either the topical white paper or the research campaign white paper, what is the so what? What is the anticipated impact on enabling space exploration to the moon and otherwise, advancing our knowledge broadly and deeply, not only for space exploration, but taking advantage of the space environment? And then finally, how might this also benefit life on Earth in that coming decade in front of us, as well as in the space environments in which we'll continue to operate and to explore together? So I'll close here, and I'm happy to take any questions. Again, I want to appreciate and acknowledge your time, not just in the workshop today, but in forming this process in the white papers and beyond. Thank you.
Great. Thank you, Krystyn, for that very informative talk. We do have a couple of questions in the chat, one from Terry Gordon. Such efforts take time. What has been learned from past decadal surveys to make this one more efficient and timely?
That's a great question. And that midterm evaluation or assessment of all kinds of decadals, not just the prior on biological and physical science, is a really great resource. I certainly found that valuable in preparing for this. So I appreciate that question. One is to make sure that we keep the aperture wide open at the beginning and not overly constrain our input in our own minds as we're developing white papers or thinking about the possible scientific frontiers. So keep the aperture very wide open at the beginning so you don't overly constrain by saying, for example, well, this is the mission stated today, or these are the assets available to us today, and perhaps all, can't see further than that. So that's the first lesson learned, is make sure that there's broad community input, big picture, blue sky thinking, if you will, so we don't filter too soon on the opportunities. The second lesson learned I would take broadly from prior decadals that were considered successful and otherwise is work very hard to not silo the scientific communities, whether it's the biological sciences from the physical sciences or the technical capabilities from either the biological or physical sciences. Work to integrate that information in iterative loops early and often so that you don't end up with a laundry list and you really end up with identifying frontiers that can be explored deliberately, collaboratively over a decade, which is a relatively short period. And then the third is to not be blind to the costs nor overly constrained by available budget known today, right? So I think that addition of the trace, the technical risk and cost evaluation, is a useful addition to make sure there's a sense of opportunity and constraints and accountability that you can work against in the coming decade. That if you go in blind to that consideration, is harder to realize over the coming decade, and harder for the whole government as well to respond to, not only NASA.
Great, thanks. And we have time for one more question. It's from Ulf Israelson. How will the committee evaluate cost and schedule for white paper input as required by the committee charter from white papers limited to 5 pages?
So that's a very understandable question. If you have such a brief document, would you get full trace from that? So I'll speak first to the process. Part of the process is that contractors with expertise in trace will work iteratively with the steering committee and with the panels to conduct that trace iteratively over the coming calendar year. We don't expect that the white papers, because as you mentioned, they're brief, would fully inform that there would be iterative requests for information, additional discussions with the community to flesh out the information needed. So I don't think you should feel in a 5-page white paper you should have all the information there that enables an accurate technical risk and cost evaluation. But putting the ideas out there, expect iterative discussions with the community, including but not only the white paper submitters, right, as we flesh out those ideas together. And a lot of that work will be done within the panels, again, iteratively with the trace contractor.
All right, great. Well, thank you, Krystyn, for your talk.